Okay, on this one, water is being pumped into an inverted canonical tank right there at a rate of 6.9 cubic meters per minute. The tank has a height of 12 meters, diameter its top is 4.5. Find the rate at which the water level is rising. Okay, so you get the deal, right? Water is being pumped into that tank and the water level's rising. Okay, so step number one is identify the rate variables. Like what rates do they mention? It says at a rate of 6.9 cubic meters per minute. Cubic meter is a volume. Cubic units are volume. So that is dV dt is plus 6 by meaning the volume of water in the tank is growing, right? Increasing. It's being pumped in. Right? It'd be water's being pumped into an inverted tank. 6.9 cubic meters. So every minute there's 6.9 more cubic meters of water, right? Like cubic meter. Think about a cube, like a cube like this. That's got volume to it, right? It's three-dimensional, length, width, height. So it's volume. That's how I know that's volume. Cubic units are always volume. So, okay. Height 12, so I'm looking for the rates. Da, da, da. Find the rate at which the water level is rising. So what they want is they want dHdt. That's what they're asking for. Huh? Let me just move this over here. Probably be good. dV dt is plus 6.9. And they're asking me for dHdt. And that's it. That's all they mention as far as rates. Okay. That's important to note. Step two, come up with an equation with the only with those letters only. Those letters only. What letters? V and H. No other letters. Well, what's the formula for the volume? Oh, they didn't give it to us there, so I'll write it. So volume is 1/3 pi r squared h. That's volume. But the problem with that equation, you notice, it has V, 1/3 pi, we don't care. Those pi is just a number, 1/3 is a number. R and H has V, R, and H. We only have V and H. We don't want R. So we have to um, plug in for R. We have to get rid of R. Well, how are we going to do that? Well, here's the trickiest step on this problem. We have to come up here and look for a relationship. Let me show you what that relationship is. Okay, it tells us that the tank is height 12 meters. So that means 12 meters is the total height of that tank, right? And it tells us that the diameter of the top is 4.5. That means it's 4.5 all the way. So I'm going to cut that in half. 4.5, cut it in half. 2.25, right? $4.50, cut in half, 225. That means this is 225 because they said diameter, which means all the way is 4.5. So half of that is 2.25. Okay. That's the whole container, right? So, but when I write in my equation R and H and V, I mean R and H and V for the water, the volume of just this volume of water, just this radius of water, just this height of water. So let's bring those in. So this right here, that's the height of water. And this right here, that's the radius of the water. So we have the, excuse me, the height of the overall cone and the radius of the overall cone. And then we have the height of just the water that's currently in there and the radius of just the water that's currently in there. And we can notice similar triangles. Have you seen that before? You can say this, whoops, I meant to do my other thing. Height is to this, height, oh brother, what did I push? Height is to this as this is to this. So I'm going to go 12 is to 2.25 as H is to R. This right here, this came from 2. So let me remove that. Let me rewrite that. So one more time. Maybe I'll start. Yes, I'll go 12 is to 2.25. So I'm doing a height. Height is right now. You can do R on the top, then it doesn't matter. Whatever. Just be consistent. Is H overall, right? 12 is to 2.25, right? This overall 12 as H is to R. Do you see that's called similar triangles? Do you remember that from here? I can put the 12 right here if it helps. You just see it. There's the 12. Well, maybe I should take that back. Just leave it where it is. There we go. Right? You see that? This height is to this side as this little height is to that side. They're similar triangles. That's called. So what? Well, then I can go diagonal, diagonal. 12R equals 2.25H. Remember, I'm trying to plug in for R. So finish solving for R there. Divide by 12. And equals 2.25 over 12. Let's go to Desmos. 2.25 over 12. 2.25. Hopefully it's clean. Yeah, 0.1875. 0.1875. 0.1875. H. There we go. I've got a relationship between R and H, the radius of the water and the height of the water. The radius will always be 0.1875 times the height. So, okay, so what? So then I'm going to take that and I'm going to plug it in right there for R. So then I will get volume equals 1/3 pi, and this will be 1875 H squared H. And now I can simplify that a little bit. Do that. So this will be V equals 1/3 pi. And I'm just going to leave this 0.1875 squared, then H squared H. All right? Does it help if I put in red? H squared H. Okay. And then so one more time. Can we simplify that one more time? 1/3 pi, 1875 squared, H cubed. Now we've fulfilled step two. Step two says get an equation with those letters. Like what letters? Only the rate letters that are mentioned in the problem, V and H. I've got rate letters with only V and H. So now step number three, d dt. Both sides, so I'm going to go d dt this side and d dt that side. So then we get dv dt. The other side, I'm just going to leave the, the 1/3 pi and the 1875 squared. That's just numbers, right? Take the derivative of this. 3 comes down. H squared dh dt. There we go. Okay. So now step 4 is always just to plug in. Just plug everything else in. Don't plug in until after the derivative because you plug in numbers, fixed numbers before the derivative, fixed number 0. It'll mess up. So, all right, let's plug it in. What we got? What are we going to plug in? What do we got here? I forget. The tank is the height is 12. Oh, wait, no, we don't. No, that. Oh, careful. That's the height of the whole tank, not the height of the water. There it is. Height of the water. Remember, so the H and the R we're using, remember the R and the H are the height and the radius of the water. The overall height of the cone is 12 and the radius 2.25. When we refer to H and R, see H and R are the height and radius of the water. So the height of the water is H, not is 4, not 12. So that'll be 4. So plug that into that. There's 4. And dV dt, I think we know, don't we? Yeah, dV dt is 6.9. So this is 6.9, so we've got 6.9 equal. We get 1/3 pi 1875 squared times 3 times 4 squared, right? Because it's right there, 4 squared, h squared, height of the water squared, dH dt. We're trying to find dH dt, so we are hot on the trail, aren't we? We're basically there. Just divide both sides now by 1/3 pi 1875 squared, 3. Now let's make that 16, 4 squared, right? So, and all of this will cancel. And the other side, same thing. 1/3 pi 1875 squared, 3 and 16. And now it's Desmos time, right? 6.9 over 1/3 pi. Let's go. 6.9 over 1/3 pi. Let's clear this. Or 6.9 over 1/3 pi. Another 1/3 pi. Was it 6.9 or 1/3 pi? 1875 squared, 3 and 16. Well, I can just use the answer button. Answer squared, because that's the answer. And I forgot the rest. 3 and 16, which is 48, but I'll just do it. 3 times 16. There we go. 3.9046. 3.9046. So 3.946. Is that the true answer? Yep. There we go. Meters per minute. That is the change in the height. So the height of the water level is going up, 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 up at 3.9 meters every minute. And so there.